Hello, everyone. Good morning, people joining from Americas, and good evening and good afternoon everywhere else. My name is Vinayak, and I'm the technical support engineer for MeshWorks and CAD Morphing tool. And I have with me Ray Cheney, the technical director for pre-sales. And today, we both are going to do a first webinar series for DEP's CAD Morphing tool. This is going to be the agenda for today's webinar. We're going to start with a small presentation just to give you a little introduction about the tool, the background, and how it's being used in different industries throughout. And followed by that, Ray is going to show you a couple of demos, live demos, on the actual components which we did CAD Morphing on. This gives you a pretty good understanding of how the tool is being utilized right now in the industry. And after that, we're going to open for Q&A. And in the meanwhile, if you have any questions, any comments, you can always type in on the chat comments, and we'll make a note of it and we'll reply to you accordingly. So saying that, let's get started. Firstly, thank you all for joining for this webinar series by DEP. Okay. As you guys have shared my screen, we're going to talk about a transformational CAD Morphing software by DEP. This software is available to use at all the client locations, and they can use it for morphing immediately after this particular session also. And we also offer training for the engineers to use the tool. Firstly, what is DEP's CAD Morpher? CAD Morpher is a part of MeshWorks suite designed by Detroit Engineered Products and has the capability, as the name suggests, of morphing CAD data in wide variety of scenarios for easily and efficiently and rapidly. Now, this tool is mainly designed to enhance the capabilities and processes and to reduce the time and effort in the product development process to deliver optimized and balanced products to the market. And again, CAD Morpher can significantly reduce CAD data generation time since the data used for CAD Morphing is actually fed from existing donor CAD data. Now, this is the process which we suggest to usage. Now, there can be different ways where CAD Morphing can be used. Now, the first thing, one of the methods where you can see is the concept CAE model that can be generated from morphing, and then you analyze for crash, NVs for different scenarios, either for powertrain models, for crash models, or CFD models, and then you make sure if the design target's met. If it's not met, if it's a parametric model, the whole loop goes on using DOE and optimization, using various optimization tools, considering the CAE model. Now, once you have optimized CAE model, you can apply those parameters on a CAD Morphing. Now, all the parameters that's done on a CAE Morphing using MeshWorks can be directly applied by using a one-button click and keep transferred to the CAD Morphing. And this particular CAD model can be sent to the freezed as a model and sent to the CAD team for further processes. So this is one of the ways where CAD Morphing can be used. Engineers are comfortable using CAE Morphing. They're doing DOEs for 100 designs, 100 runs. They can get the final design and apply all those parameters on the CAD model and then use it in this process. Now, it's very fast and robust, and runnable CAE models are automatically generated, and hundreds of iterations are run in a matter of weeks, and CAD Morphing provides design data for optimized design. So this is the advantage of running through CAE and CAD Morphing integration. And nextly, this is the CAD Morpher process. If you're looking at the CAD model, there is a donor CAD, there's a new styling theme or vehicle proportion that comes up, and then you want to morph this CAD to the new requirement. The applications can be many. The first thing which we saw for CAE, another thing can be packaging studies, human factor studies, styling impact, formability studies, early CAD for CAE or early supplier CAD. And the morph era is ideal starting point for traditional CAD. Then this traditional CAD generated rapidly from morph CAD. It's pretty time-saving. Now, as you know, we also have an extensive engineering team who also works on these tools. So these CAD Morphing tools and CAE tools are extensively tested and used by CAE engineers at the DEP. And we have observed that there is at least 40% reduction in design and engineering time by using all these tools. Now, what are the benefits of CAD Morpher? Now, DEP's CAD Morpher enabled product development can rapidly develop new vehicle derivative from an existing platform. It can maximize carry over part and processes. It can confirm performance compliance at a design stage and provide completely new CAD reference data, and it can all be done in a record time and ease of usage. Now let me quickly show you what are the applications where the Morphed CAD data can be used. As we mentioned in the packaging data for human factors, criteria evaluation, vision study, and then typical section development and start data for detailed CAD. If this can be integrated with the CAD team, they can use it for that purpose. If you want to look at analysis study for early formability and weld access study by the CAE team, and zone and limits compliance, evaluate styling team impact, then carry over bill of materials enabler, early supplier CAD generation, CAD data for CAE modeling, and morphed CAD data generation corresponding to optimized CAE model is a perfect handshake between CAE and design groups. So these are some of the few applications where we can see the CAD morphing being used today at different client locations. The CAD morphing, as I told, is a pretty easy tool. It can do typical changes. It can increase the width with the tolerance specified. It can change the location of B pillar, height of roof, and change the vision angle. All these things, as we mentioned, in a pretty quick way, and it's being used right now. This is another example where you can show the occupant space carried out by using Morphing CAD data. This is some of the typical CAD morphing studies which we have done it, and my colleague Ray is going to show in the next couple of demos of actually executing this task on a live demo process here, where you can nicely change the roof height location. If you want to do egress study or ingress study of the occupant getting in and getting out, the comfort factor study at the CAD level, it can be easily done. And all these execution is being happening at the regular CAD level. It can be a step data, IGS data, or a Unigraphics parasolid data. All these data can be easily read in and done these morphings. This is one of the upper body packaging studies which we did for the study of the comfort factor. What we had done here was a full CAD study. We got the target location, and we wanted the roof height to be adjusted to the target location. Now, the beauty of this particular program was this was a parameterized model. So you had the initial location and the final location, and there are different steps where the DOE was generated and the multiple designs were written out to understand which is the optimum one. Now, this is another application for upper body packaging study. Now, this advantage was evaluation of spaciousness and collaboration, performance evaluation to achieve zero wasted space. We didn't want to waste any waste space for packaging in seats, pillar, and door trim. So at the CAD level itself, all the morphing and parameterization was done. This is another example where the vehicle dimension and hard point changes were done to match the new styling and theme data. As you can see in this model, we are changing the morph location to accept the final location of the donor style. So you can specify what is your target, and the CAD morphing tool has the capability of morphing these tools to the target location and take the deformation smoothly throughout. These are some of the underbody packaging studies done at the different rails and floor level, where you can morph the location on both the sides so that you can increase the impact angle and then improve your performance criteria at the CAD level also. What our clients really like is the way in which this tool can work with and the ease with which of all parameterizing these details without much of user interface required or user interference required. And as we said, this tool is extensively tested, and all these morphing projects are done to make sure that the tool release is robust and has all these capabilities input into it. So it can morph the rail and also take the surrounding components with it and maintain all those fillet size and all the maintaining required for the details. For the flange match, there is minutest details that it takes care into picture, and it makes sure that you're maintaining the flange, you're maintaining the height, and you're maintaining the surrounding part with fine details. Now, this is in short the process which we have done. You have a base design that's not meeting the performance. Then you want to rapidly design modification using our CAE Morpher or CAD Morpher to meet the performance. When the modified design will meet the performance, then modified design quick for the formability study or for the different analysis, you can take it. This design is updated using CAD Morpher that meets the performance and formability, and the new CAD can be input into the full model. This is just the process of how CAD Morphing has the output from the CAD model can be usually used for the part formability process, for the die process, for the blank optimization. These are some of the test cases which we have carried out before we release this tool. And this is another nice example where we carried out with the headlamp, where the new headlamp is marked and made to fit the housing of the current model. So there is no change to the body and interface point, and the only change is happening is in the new headlamp design, new headlamp shape, which is just marked to accept the design of the donor vehicle exactly. So by doing this, there is no much big design change required, which would have increased the program time totally. Another application for this CAD Morpher, for the section development using Morphing CAD Data. Now this Morphing CAD Data can be given to the designers, and they can sections derived from the Morphing CAD, but if you're done with traditional part CAD, it can be rapidly derived from sections surfaces from the Morphing CAD. Usually what happens was, this is a clay modeling, this is the actual process. We conceptualize the modeling, clay modeling, they would surface it and then do rendering, each taking 1 to 2 months for each time. But using a MeshWorks and Morpher driven process, we've observed that in a matter of 1 or 2 days, the whole process can be done. We can generate the 3D morphing for the fascia. This is literally, we did the whole morphing of the fascia in a matter of 1 hour, and the original rendering and the morph data on the left and right, you can see the combination. So we would do all these things in a very rapid amount of time, and it's the ease with which you use it. We're confident that users would really like this tool. So this is another CAD morphing at that particular project which we carried out. The front overhang, the wheel opening change, the wheel flare, all this was done on the original CAD model itself, and the exported CAD was ready to be used for future model processes. The packaging study, the Morpher was integrated. The styling and engineering software will provide the real-time packaging feedback when the exterior panel are restyled and carry over for the internal components. The restyling for the packaging components to increase the clearance for the powertrain component. For the ergonomics evaluation, if you want to have integrated styling Morpher to provide dynamic feedback for the ergonomics impact when a new styling theme is considered. So the new styling theme can be considered to change the vision angle to ergonomics evaluation. And here we're using the vision fish analysis for interior and exterior study to understand how the vision angle can be easily changed. Now, FE mesh generation using CAD Morph data. We're just confident to tell that the data generated by CAD Morpher is a very high-class data of the level class A, and this can be used for further processes. So this particular CAD Morphing tool can be used by different groups, either by the pure CAD group for doing all the ergonomics and vision fish analysis study, or by the formability group, or by the CAE group to do all the final changes and apply those changes on the CAD level. Also, by early supplier design, development integration using Morph CAD data. These are some of the test cases where you get the supplier CAD data and the Morph CAD data, and all these things can be morphed and combined in the supplier and given as a GT format data also using a CAD Morphing tool. There are various applications, as we mentioned, and sometimes the users themselves are finding out the different ways in which this tool can be used into their processes. And like visual concept review, design review, service and process documentation, and supplier purchasing. So these are some of the applications which we are seeing right now. This is one final slide which I wanted to show before before handing over the control to our colleague, where he can show to you everything on the live model. Like this is a typical design cycle where you see the engineers without the CAD Morphing data are involved at very late stage. So you see, without the CAD Morpher, there is traditional architecture, concept data, and then the program peaks up. So this will increase the program duration. But if you have the CAD Morpher, the initial stage itself, all the design changes can be at the initial level or the simultaneous level and can be increase the program time and achieving the milestones pretty quickly. This is what our experience has been. As we told, we extensively use our tool in our engineering department. The conventional process like underbody strategy, chassis subdevelopment, underbody structure and chassis, all these things takes around 45 to 49 months in a typical process. But using a DEP process, since the engineering and the design changes are involved at the early level itself, we can cut down the time less than half, by around 26 months, and you complete the whole program cycle. So thanks guys, this is something which we wanted to show for the presentation. Now let us quickly jump to our live demos which we want to show. So all these things which we have done till now, we want to show it in the form of two examples. The morphing examples using the CAD Morphing tool, where we would like to show the morphing done at the outer CAD level, body side outer, where you change the B pillar height, width, and roof pillar height. We will do this on the live, and we will show another example where the morphing, and we have an optimized FE model, and you want to capture the changes you made in the FE model at the CAD level. All right, you want to take it? And then after this, we can open for question and answers, and we can go ahead with this.
Good morning, everyone. This is Ray Cheney, joining from DEP. As Vinayak said, I'm Technical Director of all the pre-sales and product development work done here at DEP. And as Vinayak talked about, the first demo that I'm going to show you a live demo of how quick and how easy it is to create some parameters on the body side outer component, and how to quickly morph it and create different parameters for potential one-time changes, or we can do parameters for DOE studies. So the first thing I'm going to do here is create something called a control block, and I can do this in a manual method or automatic method. So when I go to Scan Manual, I'm just going to quickly create a series of blocks. This methodology works in such a way to where these control blocks create a parametric relationship between the CAD Morpher and all the CAD components, meaning that when I create these blocks and I start to move these blocks, anything that's inside the blocks are going to move along with it. Now, I'm sketching this in a 2D level to eventually extrude this to create a full control block on this body side outer model. Now just a few more clicks, and I'll have my complete control block to where I can do a multitude of different design parameters. Now, if I turn this and give you an isometric view, you can clearly see how these are actual blocks that's been created on the CAD portion. So now I'm going to create that parametric relationship to where I'm going to pick my control block for the points to be moved or translated. And I'm going to also pick my CAD because I want any portion that's within this block to actually be translated or deformed. So I'm going to give it a name. And now I'm going to go to my Parameterization tab, and I'm going to start creating parameters. Now I'm going to make that set that I just created active. And the first parameter that I want to create here is I want to have some control over the B pillar. So now I have the capability to where I can go in multiple directions. And for this parameter, I want to go in the X direction. I'm going to put it in value of -50 and 50. I'm going to set that parameter. I'm going to give it a name as P1. Now I'm going to create another parameter to where I want to change the roof height. And I'm going to select that one for the Z direction, and I want to go 50 millimeters. I'm going to also give that a name. Now I'm going to select one last parameter here to where I want to change the roof angle, or windshield angle rather. I'm going to also go in X direction. I'm going to say negative 60. So now I've set three parameters, and now I want to review these parameters. The cool thing about MeshWorks, I can review these parameters and review only one parameter at a time, or I can review how everything accumulates to make sure that I don't have any kind of conflict between my parameters. And you can see in my first parameter, I'm able to move the B pillar, and I can keep it in a location of negative 50. I can go to my second parameter, and now I can change the roof height. And I'll keep this at a location of positive 30 in the Z direction. For my last parameter, the windshield angle, you can clearly see I'm able to nicely create an angle change for the windshield area. And I can do this and I can see the cumulative effect to make sure that I don't have any kind of conflict in any of my morphing scenarios. So now, as you can clearly see, I can take all three of these parameters and I can generate various designs with different combinations in order to generate an optimized model or for any kind of DOE studies. So you can see how easy that was to create a multitude of designs just by, within 5 minutes, I'm able to generate multiple designs using this quick method of control block creation. And I can impose any of these features and any of these movements or translations on the CAD geometry directly. Now, as Vinayak spoke about earlier, that's the first, that's one of the ways that we can do any kind of changes on our CAD geometry. The second way is we have something called imposed deformation. Now, the imposed deformation is done in such a way to, let's say if we were analyzing everything from the mesh level, and we figured out what our optimized design is going to be after running a multitude of DOE studies. So as you can look at the first model, this is the baseline mesh, and this is the initial input model of where we started. So now we've gone and we've done multiple iterations on multiple designs, and now we've basically generated an optimized model. So now you can see the difference between the two. So we have a baseline model, and then we have a morphed mesh. Now, I was going to ask the question, how can I take my morphed mesh and pass it along to the CAD geometry? That's where the imposed deformation is going to come into play. So now we have the baseline CAD, and we want to impose the deformed shape onto the baseline CAD. By clicking on the imposed deformation, we need three inputs. The first input is going to be my CAD. Second input is going to be my baseline mesh. Third input is going to be the morphed mesh. And I'm simply going to click Impose. So what's happening here is it's going to recalculate the NURBS equations, and it's going to take the baseline model, and it's going to look at its baseline position, and it's going to look at what the morph position is, and it's going to impose that movement and those shape changes directly onto the CAD. And in less than a minute here, you'll see all these changes happen right before your eyes.
And the good thing here is the morphed CAD, which we're going to get from the result from here, this can be exported as any format you wanted. It can be used for further study. And I guess we got the result in maybe in like 45 seconds to 1 minute, where the ribs have all captured those changes. And you have a baseline CAD, which had the thick ribs and the original one, and you have the morphed CAD, which can be exported as IGS or a step or any kind of format you wanted here.
So now you can see how we quickly and easily impose that new mesh shape onto our CAD geometry.
So the advantage here is you do CA iterations, you get an optimized model, you don't have to spend your time again in applying those things to the CAD or again wait for like a couple of months for the CAD team to come and do it. But here itself, you can quickly come and use this morph as a baseline design where all the nice flanges are captured, the ray fillet is captured, and it's the class A data as we mentioned, and can be further used for building the baseline CAD in a quick amount of time.
Correct. And just to further elaborate on what Vinayak is saying here, this is not like what you would see in an FE to surface generation. This is high quality surface data. You can see that we are able to maintain all our fillet geometry, all our planar surfaces, all of our holes, and we can hand this over to all the designers, and they can import this into any of the CAD packages and evaluate all the changes that were made to get an optimized model. Now, with that being said, this is going to conclude our demos, and we're going to open up any questions here pretty soon. But before we do that, I just want to thank you all for attending this webinar, and we really appreciate everybody's time taking to look at all the functionalities that we can present here and that we can provide to you as a solution here at MeshWorks. Thank you.